What is finite element analysis? FEA is a method engineers use to predict how a part reacts to real-world forces such as stress, heat, vibration, and fluid flow before it's manufactured. In FEA, we turn a part into small shapes called finite elements. These elements are connected at points called nodes. This entire system is called a mesh. During simulation, we add constraints and forces, and the software uses linear algebra to calculate stress levels within the mesh. This video will cover how to set up an assembly, tetrahedral meshing, and a von Mises stress simulation. Stress simulation is important so we can design parts that don't break easily. For example, we might want to know how much force I can exert on this handle before fatigue failure. Let's model this. Today, we're going to learn how to do finite element analysis on Siemens NX using the 2D mesh technique. Unlike 3D meshing, it's faster to compute, but it might ignore important interactions between parts. We're first going to open an assembly. It's pretty simple. We have two bolts holding two plates together. First thing first, click on Application. Click Pre-Post. Click New FEM and Simulation. Make sure Idealized Part is checked. Click OK and Create Solution. Click OK. Click on the Assembly drop-down menu and hover over the idealized part, the one with _I. Click Make Displayed Part. Click OK on the warning. Here we have the idealized part. Since there's a feature that can make a bolt mesh automatically, we can hide the bolt models. Right-click and hide these bolts. Click Promote, select the two plates, and click OK. To convert these into 2D objects, click Midsurface by Face Pairs. This converts the 3D objects to a single surface in the midpoint of each object. Click Automatically Create Face Pairs. Click OK, and this is what you should see. This used to be the bottom. This used to be the top. And this is the plane that the two plates touch. Once we're done, click Change Displayed Part and switch over to the FEM file. As you can see, it's not updated yet, so click on the Polygon Geometry dropdown and click Recreate and Update for each object. So now we have 2D objects. Click Mesh Collector, select 2D for element family. For materials, let's go with 6061 aluminum for the plates. Since it's a 2D object, we'll need to define the part thickness. In our assembly, our plates were 1 cm or 10 millimeters. Click OK. For collector type, thin shell. Click OK. Click 2D mesh. Select the two plates. Let's talk about element size. The smaller the element size, the higher the accuracy, but it would require longer compute times. If the element size is set too big, it's easy to miss small stress concentrators. On parts with small tolerances, I start with a finer element size, but for larger parts with larger surfaces, I start with a larger element size. What I usually do is I start with a medium element size and iterate lower to see what stress levels converge to. In our case, let's make the element size 3 millimeters. Click OK. It's time to add the bolts. Click More, which is next to 1D connections. Click Bolts Connection. This window is for bolt properties. For Destination Collector, under Shrink Elements, Click New Collector. Create Physical. Click Show Section Manager. Click this I-beam icon. Let's assume our bolt is a rod with a major diameter of 10 millimeters. Click OK, close, and choose material. Let's do IC 4340 steel. Rename. OK. We now select the edges for the bolt head and the nut. Click OK. It should look like a spider web that connects the two plates. The main drawback of 2D meshing is we can't see the plates interacting with each other. It's now assumed to be frictionless. Click Change Display Part and the simulation file. OK. To set the center of rotation, click View, Fit, and press Ctrl F2. Click Load Type, Force. In case we want to apply a force to a node, click Selection and choose Node from Type Filter. Let's say we want to apply a force along this edge, 1000 newtons along this direction. In 3D meshing, we would see arrows along the edge, but since it's in 2D, there's a force label instead of arrows. Let's add a user-defined constraints, select this edge, and make all the degrees of freedoms fixed. Click Solve. OK. Under the Results dropdown, right-click and Open. Open this dropdown and double-click on the elemental stress. You see there's a stress near the bolts. Unfortunately, we cannot see interactions between the top and bottom plates. We can only see interactions between the top plates and bolts. I personally only use 2D for rough estimating minimum part thicknesses. Instead, I highly recommend using 3D meshing for higher accuracy. In the description below, there's a video on 3D meshing. And there we go! We just did finite element analysis using the 2D meshing method.